My name is Tony Coviello. I'm a structural engineer with Summit Engineering, and I'm also principal at Summit Engineering. We're here today at 175 Market Street in downtown historic Portsmouth to review the aspects of 175 Market Street and the renovation that's going on here. And as part of the renovation, we're going to try and restore the aspects of the older building and add on to it with a new addition of approximately the same square footage. Besides the design of the new building and the structural engineering involved with that, we were brought in to restore the older portion of the building. And what we found is the three major areas we're tackling. That is the deterioration of the brick facade itself, the material, the deterioration of the parapets, and the corrosion of the ferrous elements throughout the building, such as lintels and window clasps. The brick deterioration that's going on in this building is largely due to the fact that they painted the building sometime in the past, and the paint has caused an inability of the brick to really allow the moisture to leave it in an efficient manner. The moisture is getting hung up behind the paint, and it's deteriorating the brick through freeze-thaw damage, and so we're going to try to remove that paint from the building in a manner that doesn't destroy the brick or the mortar and leaves it in a situation that it was when it was first built, hopefully, and have that look. The second thing that's going on in the deterioration of the building is part of the bricks were not very well produced at the time period. The controls in making brick in the 1830s wasn't as good as we have today, so as a result, some of the bricks are just not very well made. We're going to try to replace some of those where we can and restore the ones in place where that is the most appropriate course of action. So we're going to take the paint removal process in a two-step process. The first thing we're going to do is a chemical process. We're going to use a cathedral stone product, an S-series product, coat the brick. That will deteriorate the coating in a manner that will leave it inert. Even if the coating is lead-based, we should be able to remove it and have it collect the debris from that removal process and throw it away in a non-special way. It's not a hazardous material at that point. We expect some of the paint will be remaining after that, and we're going to go to the next phase would be through a sandblasting technique, but sand would be much too abrasive of a medium. It would cause harsh damage to the brick facade itself. So instead of a sand, we're going to use a soda ash. Soda is much finer, it won't deteriorate the brick behind it, and hopefully when we're done that process, all the paint will be removed and the brick will be left in a manner much more similar to when the building was erected in the 1830s. So the north and south walls of this building have firewalls that extend up beyond the roof deck, even though it's a gable roof. These firewalls, sometimes we call parapets, have deteriorated over time. They're an area that receive high wind loads and a lot of water intrusion. We can see by the exterior that there's some cracking occurring there. So we don't really know the exact nature of the cause of the damage yet, but we're going to go inside, remove some of the brick in a small area component, get a look inside the wall, find out what's going on, and try to both remove the water access to the brick and repair any deterioration that's occurred. Well, that'll occur after an in-depth inspection of the wall at discrete locations. And the last aspects of the building that we're looking to restore are the ferrous elements or the iron-based elements in the building. The window lintels and door lintels are largely iron-based materials, either iron itself or steel. They have corroded over time, and with corrosion they've expanded, causing cracking in the brick facade, and through the multiple wipes of the brick walls. We're going to have to go and determine the extent of the damage, rebuild those areas, and we're going to replace the iron-based elements with either galvanized steel or other materials that aren't susceptible to corrosion and expansion, so it won't cause any further damage to the facade, and we can repair it. The other aspect that we're looking at in terms of iron-based products is the front of the building, or the facade on the street side, has iron clasps that are used to hold the windows shutter opens. The original window shutters when the building was erected in 1830. These are really historical elements that we want to preserve but are causing damage. So we're going to remove those iron clasps, cut off the iron portion of it that gets inserted in the building, weld on stainless steel elements and insert them back in the building. So for the casual observer would never know anything was changed, but no longer causing any damage to the facade. So the more traditional structural engineering aspect of this project is the 30,000 square foot addition to the east and north of this building. That portion of it is a big challenge because the existing building has small floor-to-floor heights and really shallow floor depths that really don't relate well to what are more common building materials of bar joist and steel. So for what we've chosen for this project is a precast hollow core plank, concrete plank floor system that's really shallow, will be able to match up with the existing building. That'll allow the occupants and the users of the building to not have to go up ramps or stairs. And it's really, we're really excited about it because it really showcases how Summit Engineering can provide really unique engineering services for older buildings that where normal building materials don't really blend well with it. And so I think at the end, what we're going to end up with is a historic building with a new addition, blends the two well together, a preserved building, and allows the occupants to really appreciate the old and the new.